Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our reservoir engineering playlist, and today's topic is about benchmarking recovery factors. Okay, so I will use this as reference, benchmarking recovery factors for carbonate reservoirs, key challenges and main findings from Middle Eastern field. It's a very good paper, okay, so you can find it on the internet, download it and read it. And today's topic is about building block of recovery factor, again from this paper, all right? Okay, so talking about building block of recovery factor, most of us probably already know that we can calculate the recovery factor using this operation, using this formula. So recovery factor is the result, the product of microscopic displacement efficiency, aerial sweep efficiency, and vertical sweep efficiency. Microscopic displacement efficiency, aerial sweep efficiency, and vertical sweep efficiency. Okay, suppose we have very good, property for all of this item. Let's say I have microscopic displacement efficiency of 89%, aerial sweep efficiency of 89%, and also vertical sweep efficiency of 89%. Then my recovery factor is not 89%. My recovery factor will be a bit lower, and it is 70%. You can just calculate it. The product of this, and that, you get 70%. Okay, so we know that we will leave behind the oil in our reservoir quite a lot. There are still a lot of oil left behind in our reservoir. And that's a given. That's the given situation, the given complicated situation that it's natural. Here we can say that it's impossible to extract 100% of the oil from the reservoir. Okay, so now the issue is not how to get 100% the recovery factor. No, the issue is to understand what is the mechanism behind the recovery factor and what can we do, all right, to increase the recovery factor, okay, to get the oil as much as possible. And to know what to do, we need to know the building block of recovery factor. It's not about getting 100%, that's impossible. It's about getting as much as possible. And to do that, again, we need to know the building block of recovery factor. Okay, so let's now, using this information from this paper, let's break down each of these elements. So the first one is microscopic displacement efficiency. Okay, talking about this element, it's all about, this is very important, rock and fluid properties. Okay, none other than that. So it's about fluid properties, rock property. Okay, so if I zoom in, microscopic displacement efficiency is controlled, is governed by the fluid properties, the porosity types, permeability, wettability, capillary pressure, and relative permeability. So it's the nature. It's the microscopic nature of our reservoir, which comes from the fluid and the rock. Okay? So that's it. And then let's continue. What about aerial sweep efficiency? So the building block of aerial sweep efficiency are actually reservoir specific and driven by exploitation strategy. Okay, and if we break down the reservoir specific elements of it, we can know that aerial sweep efficiency is controlled by the faults that we have, the fractures, compartmentalization, spatial heterogeneity, structural depth, the height of the hydrocarbon column, and then permeability in X direction, Y direction, and also permeability divided by porosity ratio, and then mobility ratio. All of this will will control the areal sweep efficiency. Okay, so it's reservoir specific. It's, yeah, you can say it's given, it's nature. Nothing you can do about the faults, nothing you can do about the fractures. Yeah, maybe you can do something to, you know, to avoid reactivating the fault, or to avoid generating fractures. But if it is natural fault, if it is natural fractures, natural compartmentalization, then nothing you can do about it. Okay, but still, regarding areal sweep efficiency, we have something to do, which included in exploitation strategy. All of this will control the areal sweep efficiency by a lot. Okay, the influence, the effect can be quite significant. Okay, so we can do, or we can have something to do about this by setting the number of wells, the type of the wells, whether it is vertical, directional, or deviated, or horizontal well. Okay, all of that, all of those things will control the areal sweep efficiency. So we can do something about it. If you want to get areal sweep efficiency as high as possible, then you can do something about this number of wells, the type of wells that you will select, all right? And then the spacing, well spacing, the pattern, maybe for your water flood reservoir, you can set the pattern in such a way that you will increase the areal sweep efficiency. Maybe pattern water flood, I don't know, maybe irregular pattern water flood, maybe 5-spot, 9-spot, all right? Something about that, something like that. And then if you decide to make horizontal well, the length, okay, the horizontal well length will also govern the aerial sweep efficiency. And then completion strategy, where to put the completion, where to put the perforation, the thickness of the perforation, the intervals, something like that, okay? And then the percentage of the perforated interval, whether it is, whether you will open, whether you will make like open hole, or maybe you perforate all of the thickness of the reservoir, or maybe just do, limited entry, partial penetration. All of those things will control the aerial sweep efficiency. And of course, also the production rates and the injection rates, the well rates will also control the aerial sweep efficiency. And vertical sweep efficiency. Okay. This is also controlled from the reservoir specific perspective by the layering, flow units, faults and fractures, the trends of the permeability anisotropy, the vertical permeability divided by the horizontal permeability, the thickness of your reservoir, again, the height of the hydrocarbon column, the vertical heterogeneity, okay, as opposed to the spatial heterogeneity that will control the aerial sweep efficiency. And mobility ratio also, plays a very significant role in controlling aerial and vertical sweep efficiency. And exploitation strategy also has significant impact on the vertical sweep efficiency. Okay, the number of wells, the spacing, the completion strategy, perforated interval, the percentage of the perforated intervals, and production and injection rates. Okay, and the horizontal well length sort of only controls the aerial sweep efficiency. It has, weak significance for the vertical sweep efficiency, although it can also impact the vertical sweep efficiency. All right, so all of these things will be the building block of the recovery factor. Okay, the existence of some of these things will increase the recovery factor, and some will decrease the recovery factor. Okay, If it is about reservoir specific, if it is about rock and fluid properties, you can do something about it, but not that much. Okay. But you can focus your effort on the exploitation strategy by creating first a good FDP field depletion plan, okay, by calculating, estimating the number of wells that you will need to drain the reservoir to increase the recovery factor, that is to increase the aerial and sweep efficiency, and then determining the optimum production and injection rates, you know, deciding where to put the perforation and how much, how thick the interval will be for the perforation, something like that. All right, so yeah, that's it. These are the building blocks of reservoir. I mean, these are the building blocks of the recovery factor. Again, recovery factor is the product of microscopic displacement efficiency, aerial sweep efficiency, and vertical sweep efficiency. And each of these elements, is controlled by these, features, by these parameters, by these phenomena. Okay. Some will be related to the nature, to the reservoir specific, rock and fluid properties specific, and some will depend on the exploitation strategy in which we have significant role. Okay, so I think that's all. Again, this is about benchmarking recovery factors. Thank you so much for watching and see you again in the next reservoir engineering videos. Thank you.